So let's do a few examples to see how we can apply these equations of motion, right? Usually what I do when I'm reading these questions for physics, I usually pick out the important parts and put them in their right symbols. So that's what we're going to do as we're reading this question. So this question is saying, there is a car moving at a velocity 54 kilometers per hour. It's already moving, so which means my initial velocity of this car, initial velocity for this car is 54 kilometers per hour. It's already moving, right? So this car is moving at an initial velocity of 54 kilometers per hour, and it accelerates uniformly at a rate of 2 meters per second squared. So my acceleration is 2 meters per second squared, right? I don't know what's going on with my writing pad. It's slippery, sort of, because it's now making it seem like I have a bad handwriting. I don't think I do, but anyway, I digress. So my acceleration is 2 meters per second squared. What it wants is calculate the distance traveled. So it wants us to calculate the distance traveled from the place the acceleration began to that where the velocity reaches 72 kilometers per hour. So this thing is going to reach 72 kilometers per hour somewhere there, and we need to calculate the distance traveled to cover that distance, right? Alright, cool. These are the things that I have, and I'm supposed to calculate the distance. So the reason why I put them in symbols like this, it makes it easier for you to think of the equation of motion that you are going to apply, right? So the first step when you're solving such a question is, let's look at our units. My velocities are given in kilometers per hour, and my acceleration is given in meters per second. That is a problem. Everything needs to be in SI units. It's best to use SI units or to use the same unit base. But for you not to be confused, it's best to use SI units. So how can I convert my 54 kilometers per hour into meters per second? Because for velocity, the SI unit is meters per second. Same as for V, I need to convert 72 kilometers per hour into meters per second. Basically what you do is, just think about it. Here it's saying, in 1 hour, I travel 54 kilometers. Therefore, in 1 hour, I'm traveling 54,000 meters, right? That's what it means. But what is 1 hour? 1 hour is 3,600 seconds. I'm traveling 54,000 meters. If I'm to travel so what about in a second? Because velocity says per second. So per second, how much am I traveling? How did I get 1 on the left hand side? I divided by 3,600, right? That's how I got 1 on this side. But what I do on the left hand side, I also have to do on the right hand side. So it means on the right hand side, I also have to divide by 3,600. When you do that, the left hand side becomes 1 second, and the right hand side is just going to become 15 meters per second. So it's going to be 15 meters. So therefore it means in one second I'm moving 15 meters. So it means my U is actually 15 meters per second. Same applies for my V. My V is saying in 1 hour I'm moving 72 kilometers. Therefore in 3,600 seconds I am moving 72,000 meters. So 72,000 meters. But what about in 1 second? I divide by 3,600 on the left hand side. I will also have to do it on the right hand side. And you see that this becomes 20 meters when you divide both sides by 3,600. So it says in 1 second, I'm actually moving 20 meters. Therefore, my V is equal to 20 meters per second. That's what it means, right? So now I have my updated U, I have my updated V, I have my A, and I have my, and I need to find my S, right? I need to find my S. And start looking at the equations. Let's write them down. V is equal to U plus AT. That is my first equation. My second equation says U is equal to UT plus half AT squared. That's my second equation. My third one says V squared is equal to U squared plus 2AS. Let's vet or let's vet the first equation. Is this going to work? Probably not. It might work, but it's going to be difficult for us. It's going to give us work because of this nasty thing here. Time. Time is, I'm just saying this nasty thing, but it's going to be nasty because we do not have this. See the advantage of writing things in symbols when you're reading the question, because you can automatically pick out what you have, what you're looking for, and what you don't have. I do not have my t, so which means this equation that is dependent on me having my t, it's not going to be useful. Also, I'm looking for my s. This first equation does not even give me an s, so this is totally wrong. Out. This is out. Let's look at my second equation. At least it's calculating the s, which is 1 down. 1 factor down, we are happy. But it's also dependent on me knowing my time. That is an issue. I do not know my time. So we park it on the side. Let's move to the third equation. Let's see. Does the third equation have an s in it? Yes, it has an s, which means if I play around this equation, I can make s the subject of the formula, right? And calculate my s. Do I have my v in my information that I was given? Yes, I have my v, which is this one that I just updated. Do I have my u? Yes, I have my u. I updated it here. Do I have a 2? 2 is just a thing that you can punch in the calculator. You obviously have a 2, so I have my 2. And do I have my a? Yes, I have my a because I was given my a by the information. Happiness. I think the third equation is the one that we need to use because it has everything, and I'll just clean it up to make s my subject of the formula like this. Making s the subject of the formula gives me s is equal to v squared minus u squared over 2a. Just do a bit of algebra, you see that that's what you get, right? What is my v squared? V is just 20. So here I'm going to say 20 squared minus, what is my u? 15 squared all over 2. What is my a? 2 times a, which is 2. So this is equal to, when you punch all of this in a calculator, as you are allowed to do, you see that becomes 43.75 meters. So it means my distance traveled is 43.75 meters. Straightforward like that. Easy stuff. And we tested our equations of motion. So like I'm emphasizing, for it to be easy for you, write out the symbols like that. When I was struggling with physics, so the guy was a stream ahead of me, Kurai Mombeshora. He's the one I went for like a mini tutorial because he was one of the smartest guys I've ever talked to. So Kurai was like, no, Easton, just write your symbols. Because I couldn't answer your question. Everything was just up in the air. I didn't know what they were talking about. 54 kilometers per hour, what is that? I couldn't even picture that it is you. I couldn't picture that. But then when he taught me this method of writing it out like this, when you're reading the question, write out, that's my initial velocity, that's my a, that's my s, that's my v, that's my t. What am I looking for? When you write it out like this, it is easier to translate it into equations and put those symbols into equations. If you have another method that works for you, perfect. But this is the way I usually do it. And the second point is make sure that your units are in SI units. Most of the time, you need to put them in SI units for you not to be confused. If you know how to work out to them in kilometers per hour and come up with SI units like meter, well and fine. But the best way that I guarantee you get all marks in an exam or a test is to put them in SI units first, because they could be hidden. They probably are hidden marks to see if you can convert that 54 kilometers per hour into meters per second. There could be method marks here, and you wouldn't want to miss those method marks, right? Anyway, enough chatter. Let's look at the second part. The second part is saying, okay, now that you've calculated this, what is the time taken? That's what it's asking. What is the time taken? Okay, now we are calculating our t. Now they want to know the t. Can we use the first equation? We sure can, because we have our v, we have our u, we have our a, and we can just make the t the subject of the formula by doing this, v minus u over a. Straightforward, right? So this is equal to, what is our v, which is 20, minus our a, which is our u, which is 15, divided by a, which is 2. So the time it took is 2.5 seconds. So it took 2.5 seconds to travel through 43.75 meters at that acceleration, starting at our initial velocity 15 meters per second, ending at 20 meters per second. Straightforward, I think. Let's look at another example. This one I'm just going to go quick because now we know the basics of doing this. We are told that we have a train traveling. This train is already traveling. When it's already traveling, you know that is your initial velocity. The train is traveling at 72 kilometers per hour, and it undergoes uniform retardation of 2 meters per second. Very important point now. Retardation is the opposite of acceleration. Basically, retardation is just the opposite of acceleration. And in physics or in maths, what is the opposite of addition? It is just subtraction. Normal acceleration is adding speed, right? It's adding speed. Speed is increasing. But when we're retarding, we are now decreasing speed. And in mathematics format, decreasing is given by a negative. So here when they say it undergoes uniform retardation, it is a uniform acceleration but a negative acceleration because it's retardation. So this is going to be minus 2 meters per second. Let me read that again. Train is traveling at 72 kilometers per hour, undergoes uniform retardation of 2 meters per second. So this is the uniform retardation of 2 meters per second. It is just negative acceleration. So this happens when the brakes are applied. Find the time taken. Oh, we need to find the time. Okay, cool. Find the time taken to come to rest. Very important point. I'm going to write the points here. Let me actually write the points there that we need to remember. There's a thing called, we've been introduced to a thing called retardation, and we've been introduced now to a concept called coming to rest, or let me just say at rest. That's a very important point. So it's saying find the time taken to come to rest, and then we are also going to have to find the distance traveled, and the distance traveled from the place where the brakes are applied, right? We are also going to have to calculate S. So now you'll be confused. You'll be like, my word, I have my U, I have my A, I have to calculate my T and my S. Let's put down the formula and then see what are we going to do. V is equal to U plus AT, one formula. S is equal to UT plus half AT squared. V squared is equal to U squared plus 2AS as the last formula, right? Now you'll be so confused because when you test all of them, this you do not have a V. There's no V here. There's no V here, right? And then this S is actually what you're calculating. The T is actually what you're calculating. So there's two things that you do not know. It's going to be complicated. You move on to the third one. V, you do not have a V. Now you're confused. Don't be. It's because of this point they told us here. The at rest. The question says, find the time taken to come to rest. So which means, what is going to be our, at the end of everything, what is going to be our final velocity, which is our V? At the end of everything of the retardation, what is going to be our V? The point of at rest is very important because at rest, it means this thing has stopped. Which means our final velocity has to be 0 meters per second because this thing would have stopped, right? It would have stopped. That is one point I wanted to emphasize. Sometimes an object will start moving from rest. They'll say an object has started moving from rest. If they say it has started moving from rest, it means its initial velocity was 0 because this thing was just chilling. It was just stationary, chilling there by the station or wherever it was. It was chilling and it then started moving. So its initial velocity would be 0. So watch out for these terms like at rest. It's very important. And things like retardation. Retardation is just going to be negative acceleration like we discussed. Negative acceleration. So So now we have our v because of the statement they told us. They thought we were going to hide our v inside the statement, but we are smart enough. So now that we have our v, can we go back to our formula and see which one works? We have our v, we have our u, we have our a. We can calculate our t from the first equation, which is the simplest equation of them all. So therefore, making t subject of the formula is just going to be v minus u over a, right? So this is equal to, what is our v? We said it's going to be 0 minus, what is our u? Our u was 72 kilometers per hour, but we do not like kilometers per hour. We prefer meters per second. And like we calculated here previously, our 72 kilometers per hour changed to 20 meters per second. So this is just going to be minus 20 divided by our acceleration, which is minus 2, which is another very important point. Our acceleration is not 2, it is minus 2 because there is retardation. So it's going to be negative 2. So this is going to be negative 20 over negative 2. So our time taken is going to be 10 seconds. So when the conductor pumps the brakes, it's going to take us 10 seconds to come to rest, or for the train to stop when it was traveling at 72 kilometers per hour. That's it. Right? First part answered. We now know our time. Let's calculate our S. Which one do you prefer? Do you prefer this one, or you prefer using this equation? You decide. Because here we have our V, we have our U, we have our A. We can make S the subject of the formula for this one. That is going to be homework. At least I should give you homework, right? Feeling like a teacher now. So this is going to be homework. Confirm that your S is the one that we are going to get when we use this equation. This is what we are going to use because we have our time now, we have our A, we have our T, we have our U. So let's use that one. S is going to be equal to UT. It's saying S is equal to UT plus half AT squared. So this is equal to, our U in meters per second is 20 multiplied by T that we have just calculated, which is 10 plus half. Our A is minus 2. That very important point. A is minus 2. It's not 2, it's minus 2 plus, I'll multiply by 10 squared. When you punch this in a calculator, you're going to see that the distance is 100 meters. So it means when we pump the brakes, we're going to come to rest after 10 seconds and would have traveled 100 meters from the time the conductor put on the brakes, and then we stop. So this introduced new factors like at rest, these terms, and something called retardation. So retardation is another name. They can say deceleration. It's one and the same thing. It's just negative acceleration. Retardation or deceleration. Interesting, right? And it also emphasized our point of picking out our symbols as we read the question, and then testing which equation works. So I hope those examples were very, very interesting. In the next video, we're going to look at motion under gravity. Here we're just looking at motion in a straight line, right? Let's look at motion under gravity. Things falling, like when we throw something in the air or whatever it is. Let's look at what happens motion under gravity. Stay tuned for that video.
Created with free version for non-commercial use.